Last lesson we learnt the product rule, which was when we had two algebraic things multiplied together. So of course the quotient rule is when we have two algebraic expressions divided. Okay, so they will be in fraction form most likely. So remember how I said for the product rule to remember VUV? For the quotient rule, you'll see on the top of that formula, you have got very similar things. You've got the VU dash and the UV dash. You've got the VUV. The only difference is now they are subtracted, which is why the order that I taught you yesterday is important, because if you always do that order, it is the same for product and quotient. Just remember to subtract for quotient, and you also divide by V squared. Okay, so that is the quotient rule formula. To set out the question, we're going to do it very similarly. The U must be what's on the top. Okay, before for product rule, it didn't really matter which one was U, which one was V. But for product rule, U is the top and V is the bottom. Did I say product? Quotient rule. Quotient rule. So U is the 2x minus 5, and the V is the 3x plus 4. So we need to find the derivative of each of those. U dash is going to be 2, just the number in front of that x, because the 5 will disappear. And V dash will be just the 3. Okay, so let's write our formula down. Derivative, so y dash equals VUV, V U dash minus U V dash over V squared. Okay, substituting into that, we're going to multiply the V with the U dash. So let's put the 2 first. So 2 bracket 3x plus 4 minus 3 bracket, multiplying the U with the V dash, 2x minus 5. And that is all over V squared. Which, I need to sub in. What is my V squared? 3. Plus, let me get rid of my square so I can fit it in properly. 3x plus 4 all squared. Okay, then all I want to do to that is expand out the top, because it's not a very complicated bracket system up there, so I can expand and collect that up. So 2 times 3 is 6x, 2 times 4 is 8. Expanding the minus 3 through, I get minus 6x, minus 3 times minus 5 makes a plus 15. Don't expand the denominator, okay, because that's not going to help you with any future calculations. It's always easier to have that one factorized. Collecting up the top, you'll see that the x's will cancel out. 6x minus 6x is gone. And 8 plus 15 makes 23 over 3x plus 4 all squared. That's it. Quotient rule. Question 2. We want to differentiate again, and we can see the fraction there with x's on the top and x's on the bottom. So we can do a quotient rule. U must be the top. So U is the 4x cubed minus 5x plus 1. And V is the bottom, x cubed plus 2. Differentiating. U dash. Bring the 3 down the front, times with the 4 to get 12x. Subtract 1 from the power is 2. The second term, we will get the minus 5. The x will disappear, and the 1 will disappear altogether. The V dash. Bring the 3 down the front, leave the x, subtract 1 from the power is 2, and the 2, the constant there, will disappear. And then we're ready for our formula. So derivative equals VU dash minus UV dash all over V squared. Subbing in. V times U dash. Because there's 2 terms in each of them, put them in brackets. So I'm going to put my x cubed plus 2, that's my v. My u dash is 12x squared minus 5. Then I want u times v dash. The v dash is only one term, so let's put that first, and then a bracket around the u.
Isn't it minus this?
Yes, thank you. Plus 1 minus in that formula over v squared x cubed plus 2 all squared. Okay, so remember, if you can't factorize it and make it nicer, you probably want to expand. So most of the quotient rule ones, we won't be factorizing the top, we'll be expanding them out. So on this one, I can do a FOIL expansion for those first two brackets. X cubed times 12x squared is going to make 12x to the power of 5. Then x cubed times minus 5 is minus 5x cubed. 2 times 12x squared is 24x squared. And 2 times minus 5 is minus 10. Then expanding the minus 3x squared into that second bracket will make minus 12x to the power of 5. Minus times minus makes plus 15x cubed and minus 3x squared all over. So it can be a bit of a pain rewriting your denominator over and over again, but you do need to do it. So looking for some collecting. Oh, there's some cancelling. 12x to the power of 5 minus 12x to the power of 5, that disappears. So the power of 3 is my next highest power in there. So I have minus 5x cubed and plus 15x cubed. So that will be a positive 10x cubed. Then looking at the squared terms, I have 24x squared minus 3x squared. So that will make a plus 21x squared. And that just leaves my constant, which is the minus 10. It's only one of them. All over the denominator. Okay, so there are a couple of questions in the textbook that will ask you to factorize your numerator once you're done. That one we obviously can't, because unless the extension people might like to have a try, but advanced people, we're not expecting you to factorize cubics, okay? So the ones that you are asked to fully factorize should be nice quadratics or something similar, easier on the top for you to factorize fully, okay? All right, so that means 9i for today.